Relations and functions. A relation is a set of ordered pairs. These are examples of ordered pairs. Each of them is in the form x, y. Domain is the set of x coordinates of the ordered pairs. The domain in the set of ordered pairs above contains 0, -3, -1, and 2. These are the x-coordinates of the ordered pairs. Range is the set of y-coordinates of the ordered pairs. The range in the set of ordered pairs above contains 5, 4, 2, and -6. These are the y-coordinates of the ordered pairs. Graphing ordered pairs. Graph the relation containing the ordered pairs 1, 6, -3, 4, -4, 2, and 4, -3. Each of these ordered pair is in the form x, y. Let us graph this on this coordinate plane. In the first ordered pair, the value of x is 1, the value of y is 6. Look at 1 on the x-axis. This is the line for 1. And then this is 6. This is the line for 6. The intersection of the two lines is 0.16. Let us graph the second ordered pair, -3, 4. Look at -3 on the x-axis. This is -3. This is the line for -3. And then this is 4. The intersection is -3, 4. Let's graph the third ordered pair, -4, 2. Look at -4 on the x-axis. This is -4. This is the line for -4. And then 2 on the y-axis. This is 2, and this is the line for 2. The intersection is -4, 2. And then the last ordered pair, 4, -3. Look at 4 on the x-axis. This is 4. This is the line of 4, and then -3 on the y-axis. This is -3. The intersection of the two lines is 0.4, -3. Find the domain and range. Let us first find the coordinates of the points. The coordinates of the first point are -2, 4. The coordinates of the second point are -1, 2. The coordinates of the third point are 1, 2. The coordinates of the fourth point are 1, -3. And the coordinates of the last point are 4, 6. Domain is the set of x coordinates of the ordered pairs. Therefore, the domain is the set containing -2, -1, 1, 1, and 4. Range is the set of y-coordinates of the ordered pairs. Therefore, the range is the set containing 4, 2, 2, -3, and 6. Making a mapping diagram. Make a mapping diagram for the relation containing the ordered pairs -4, -8, 2, -3, and 4, 7. The mapping diagram is shown below. The elements of the domain are -4, 2, and 4. The elements of the range are -8, -3, and 7. -4 is paired with -8, 2 is paired with -3, and 4 is paired with 7. A function is a relation in which each element of the domain is paired with exactly one element in the range. Identifying functions. Determine whether each relation is a function. In this relation, the elements of the domain are 1, 2, and 3. The elements of the range are 2, 4, and 7. The element 1 in the domain is paired with the element 2 in the range. So one element in the domain is paired with one element in the range. The element 2 is paired with 4. So one element in the domain is paired with one element in the range. 3 is paired with 4, and also it is paired with 7. So one element in the domain is paired with two elements in the range. So therefore, this is not a function. The element 3 of the domain is paired with both 4 and 7 of the range. Next, in this relation, the elements of the domain are 4, 5, 7, and 9. The elements of the range are 5, 6, and 8. 4 is paired with 6. So one element in the domain is paired with one element in the range. 5 is paired with 6. One element in the domain is paired with one element in the range. 7 is paired with 5. One element in the domain is paired with one element in the range. 9 is paired with 8. One element in the domain is paired with one element in the range. Therefore, this is a function. Each element of the domain is paired with exactly one element of the range. We can also determine whether a relation is a function by using the vertical line test. Let us say this is the graph of the relation. We draw a vertical line and then let the vertical line move towards the right. If it passes through only one point, then the relation is a function. If it passes through more than one point, then the relation is not a function. Let us say this is the vertical line. We can see that the vertical line passes through only one point. Therefore, the relation is a function. Another example for using the vertical line test. Let us say this is the graph of the relation. Let us draw a vertical line and then let it move towards the right. If it passes through more than one point on the graph, then the relation is not a function. We can see that the vertical line passes through 2 points. Therefore, the relation is not a function. Write the ordered pairs for the relation and then find the domain and range. For this point, we have negative 5, 2. For this point, we have negative 4, 5. For this point, we have negative 2, 3. For this point, we have 2, 4. For this point, we have 4, negative 2. The domain is the set containing negative 5, negative 4, negative 2, 2, and 4. These are the x coordinates of each of the points. The range is the set containing 2, 5, 3, 4, and negative 2. These are the y coordinates of each of the points. Determine whether each graph represents a function. Number 1. This graph represents a function. We can determine that by using the vertical line test. If we draw a vertical line here and let it move towards the right, it will only pass through one point. Number 2, this is not a function. If we draw a vertical line and then let it move towards the right, it will pass through 2 points. Therefore, this does not represent a function.